3I Atlas, rogue wanderer, or alien probe. Astronomers scramble, telescopes lock on, unveiling secrets that could rewrite the stars.
On December 18th, 2025, one of the world's most powerful radio telescopes locked onto an interstellar visitor racing through our solar system at over 124,000 miles per hour. Scientists weren't just observing it, they were listening for something that could change everything we know about our place in the universe. 3I Atlas represented something unprecedented in modern astronomy. The object's characteristics had sparked intense debate among researchers, with measurements and observations that defied conventional explanations. And when Harvard astrophysicist Avi Loeb suggested this could be alien technology, NASA threw everything they had at it. What they discovered in those 5 hours of listening would either put the alien theory to rest forever, or open a door we might not be ready to walk through. Here's what you need to understand right from the start. We're not talking about some distant object billions of miles away. 3I Atlas came within 168 million miles of Earth. That's less than twice the distance between us and the Sun. In cosmic terms, that's practically in our backyard. But distance isn't what made this special. It's what this object is, where it came from, and how it's moving that has scientists scrambling for answers. Here's where things get interesting. When scientists first analyzed the brightness of 3I Atlas using standard models, they calculated it would need to be roughly 12.4 miles in diameter. That's massive. We're talking about something potentially 40 times larger than the previous interstellar visitors. But there's a problem with that calculation. A big problem. Avi Loeb and his colleague Eric Kido ran the numbers on how much rocky material actually drifts between the stars. The statistical probability of finding a genuine 12-mile interstellar asteroid is virtually zero. The universe simply doesn't have enough large rocks floating around in interstellar space to make frequent visits plausible. Their calculations show that such a massive object could only deliver itself to our solar system perhaps once every 10,000 years or longer. So either we just witnessed an incredibly rare event, or the initial size estimate is completely wrong. The Hubble Space Telescope captured detailed images that revealed something unusual. The glow pattern around 3I Atlas has an unusually steep brightness profile, much steeper than what we typically see in regular comets from our own solar system. Now, here's the kicker. Traditional size estimates assume objects are simply reflecting sunlight. But what if 3I Atlas isn't just reflecting light? What if it's producing its own illumination? If that's true, then everything changes. Rather than a massive 12-mile object, the actual nucleus could be as small as 1,440 feet across. That's the difference between a mountain and a large building. And suddenly, the probability of this visit goes from once in 10,000 years to something far more reasonable. But what could cause an object to generate its own light in the depths of space? There are a few natural explanations. Radioactive decay from heavy elements could produce a glow, though finding enough radioactive material in interstellar space would be extremely unlikely. Thermal emission from internal heat sources is another option, but that would require the object to maintain temperatures well above what solar heating alone could provide. Or, and this is where it gets wild, we could be looking at artificial illumination from some kind of technology. This is where Avi Loeb enters the picture with a provocative question. And before you dismiss him as some fringe scientist, understand this. He's a professor at Harvard University, former chair of their astronomy department, and served on the President's Council of Advisors on Science and Technology. This isn't some guy with a blog. This is serious academic firepower asking uncomfortable questions. Loeb looked at the data and co-authored a paper asking whether 3I Atlas could be a disguised probe from another civilization. But Loeb didn't stop at the light mystery. He examined something equally intriguing about 3I Atlas, its chemical composition and behavior as it approached the Sun. Spectroscopic observations from the Very Large Telescope in Chile detected something remarkable. Scientists found atomic nickel emission in the comet's coma, the cloud of gas and dust surrounding its nucleus. This is extremely rare. While nickel has been detected in a handful of solar system comets, seeing it so prominently in an interstellar visitor raises questions about the conditions in its home star system. What makes this even more interesting is that nickel was detected without corresponding iron emissions. Normally, these two elements appear together because they're both released when dust grains break down under solar radiation. The fact that nickel appears alone suggests a distinct low-temperature process, possibly involving organometallic compounds or nanophase materials that we don't fully understand yet. The cyanogen gas detected in 3I Atlas also tells a fascinating story. As the comet moved closer to the Sun, cyanogen production increased dramatically, following a steep power law relationship with distance. This pattern suggests that the molecules aren't simply sublimating from ice like we'd expect. Instead, they might be released through photon-stimulated desorption or the breakdown of complex organic materials. Here's what really caught scientists' attention. Based on Hubble observations, the nucleus diameter is estimated somewhere between 1,440 feet and 3.5 miles. If water is sublimating directly from the surface, a significant fraction of that surface would need to be active, possibly around 20%. That's much higher than the typical 3 to 5% we see in most solar system comets. This level of activity, combined with the unusual chemical signatures, suggests 3I Atlas might be fundamentally different from the comets we're used to studying. It could represent a pristine sample of material from a planetary system with different metallicity, different formation conditions, or even different irradiation history than our own. So NASA and the scientific community had a decision to make. Do we just catalog these unusual properties and move on? Or do we take the next step and actually listen for artificial signals? Enter the Breakthrough Listen project and the 100-meter Green Bank telescope in West Virginia. This isn't just any radio telescope. It's one of the world's biggest and most sensitive. 3I Atlas was transmitting any kind of radio signal that the search was designed to detect. Green Bank would hear it. On December 18th, roughly a day before 3I Atlas reached its closest approach to Earth, astronomer Ben Jacobson Bell from the University of California, Berkeley led a team that pointed the telescope at this mysterious visitor and listened for 5 hours straight. They used a clever observation pattern called an ABA-CAD arrangement, switching between pointing at the comet and pointing at other patches of sky in an expanding fractal pattern every 5 minutes. This way, they could filter out any signals that weren't actually coming from 3I Atlas itself. After 5 hours of listening across a wide range of radio frequencies, the team's computers initially flagged 470,000 potential signals that looked like they might be artificial. But here's where the real work began. They had to eliminate every signal that appeared when the telescope wasn't pointed at 3I Atlas. After that filtering process, they were left with 9 candidate signals. 9 signals that only appeared when they were looking directly at the comet. Those 9 signals? All of them turned out to be radio frequency interference from human technology here on Earth. Cell towers, satellites, radar systems, the usual suspects. Not a single credible signal came from 3I Atlas itself. Complete radio silence. Now, before you feel disappointed, understand what this actually tells us. It doesn't conclusively rule out alien technology. Our own Voyager probes fall silent for long stretches. By the time they've traveled for as long as 3I Atlas potentially has, up to billions of years if they survive that long, their power supplies will have long since died. But what we can say with confidence is this: 3I Atlas is not an alien beacon broadcasting messages in radio frequencies across the solar system. If there's technology there, it's either dormant, broken, or deliberately silent. So what is 3I Atlas really? The majority of astronomers studying it believe it's a natural interstellar comet, and they have good reasons. David Jewett points out that the dust production rate they've measured, between 13 and 132 pounds per second, falls within expected ranges for normal comet activity. The ejection velocities of material, 66 to 6,562 feet per second, also match what we see in regular comets. Spectroscopic observations from Gemini South and the NASA Infrared Telescope facility revealed strong water ice signatures mixed with carbonaceous minerals and silicates. The water ice shows characteristics suggesting it could be chemically pristine, lacking the heavy isotopic signatures we typically see in solar system comets. This water could have formed billions of years ago in a completely different stellar environment. The fact that we haven't detected volatile gases like diatomic carbon in large quantities isn't unusual either. The self-illumination hypothesis also faces challenges. If we're generating its own light through some kind of nuclear process, it would need to produce roughly 10 gigawatts of power. That's equivalent to several large power plants. Maintaining that kind of energy output over millions of years of interstellar travel would require either an enormous fuel supply or technology far beyond our current understanding. But here's what really matters. The James Webb Space Telescope has this object in its sights, and its infrared capabilities could reveal unprecedented details about its temperature profile and energy output. There's also an exciting possibility involving Mars-based observations. When 3I Atlas passed close to Mars in early October, there was talk of using the HiRISE camera on the Mars Reconnaissance Orbiter to capture high-resolution images. This could give us our best close-up look at an interstellar object's surface and potentially resolve the question of whether we're seeing reflected sunlight or self-generated illumination. Water production measurements from the SOHO spacecraft's SWAN instrument revealed that on November 6th, when the comet had traveled out to about 130 million miles from the Sun, it was spewing water at a rate of approximately 20.7 pounds per second. To put it another way, imagine filling an Olympic swimming pool every few seconds. Over the following weeks, water production dropped steadily, falling to between 0.65 and 1.3 pounds per second by early December, about 40 days after perihelion. This decrease follows a pattern that astronomers recognize from solar system comets. As a comet moves farther from the Sun, reduced heating means less ice sublimates from the nucleus and activity winds down. The fact that 3I Atlas behaves this way suggests that despite traveling through interstellar space for potentially millions of years, it hasn't fundamentally changed from the icy bodies that formed in our own solar system's distant past. So why did scientists scan 3I Atlas for alien signals? Because looking is what science is all about. Even finding nothing tells us something. In this case, the nothing tells us that 3I Atlas isn't broadcasting in radio frequencies. We know that now. We didn't know it before. And can you imagine if it had been transmitting and we missed the detection just because we were too reasonably certain it was natural to bother checking? As Paul Ginsparg of Cornell University, founder of ARScriv, told Science Alert, these discussions give non-scientists an indication of the sorts of amazing observations being made, the fun that scientists have thinking about them, and the possibilities that are out there. The Vera C. Rubin Observatory has just begun operations and will detect dozens of interstellar objects annually. We're about to get the statistical sample we need to understand what's normal and what's truly anomalous. 3I Atlas now leaves our solar system behind, traveling for millennia before approaching another star. But thanks to the Green Bank Telescope, Hubble, SOHO, and all the other instruments that studied it, we've captured a detailed snapshot of this messenger from the depths of space during its brief visit to our neighborhood. Whether it's a natural wonder carrying pristine water ice from another star system, or something we don't yet understand, this visitor is reminding us that the cosmos still holds secrets that could change everything we think we know about our place in the galaxy. If you found this deep dive into 3I Atlas fascinating, hit that like button to help this video reach more space enthusiasts. Subscribe to the channel so you don't miss our next investigation into cosmic mysteries. Drop a comment below telling us what space topic you want us to explore, and share this video with that friend who's always talking about aliens.